Hello, good morning, and thanks for joining me again. Thanks to particularly those joining me live on Blue Jeans and on Facebook. I really do appreciate you taking the time to tune in. So this is going to be Sprinkler Talk episode 45, looking at pipe supports and pipe finishes. Happy April the 1st, everybody, and I hope you have a good Easter weekend coming up. Let's get started on pipe supports and pipe finishes. So first of all, we're going to look at some of the kind of the boring stuff, I suppose. So this is 17.2.1, which is talking about a list of requirements for pipe supports in under BSEN 12845. Some of these are like really obvious, but some of them are a bit more interesting to talk about. So first of all, you must fix them directly to the building as a sort of primary way of fixing. But interestingly, it says if necessary, you can fix pipe supports to machines, storage racks, or other structures. Which I found that interesting that it wasn't sort of ruling that out. You can do that. I guess that's quite rare to do that, and obviously be avoided where possible. Not used to support any other installation. So that's quite common, where other services will kind of steal support from other people. I've seen that around and about where you've got a pipe hanger, sprinkler pipe, and then underneath. There's now a cable tray which is supported off the sprinkler pipe, which is supported off the ceiling. I think that the point there is that everything is calculated as far as load-bearing strength is concerned. So if other services are then kind of piggybacking off the same support, it'll probably be fine. But it hasn't been calculated, and therefore we don't know the total weight, and therefore it shouldn't be done. They should be of the adjustable type. We mostly use threaded rod and nuts to tighten up the brackets and also to secure it in place. Support shall completely surround the pipe and shall not be welded to the pipe or fittings. Okay, so there are different types of hangers and brackets, but all of the types that we use completely surround the pipe, so the pipe can't sort of jump off and come loose. Structure must be capable of supporting the pipework. Well, that's pretty obvious. Pipes bigger than 50 millimeters shall not be supported by corrugated sheet or acerated concrete slabs. So again, there's kind of a special note there that yes, in general, everything has got to be capable of supporting the pipes, etc. But you must not use corrugated sheet or the concrete slab blocks when the pipe is above 50 millimeters. Distribution pipes and risers shall have a suitable number of fixed points taken into account actual forces. So that just means bracing it in sort of different directions, thinking about how forces may come into contact with that pipe, which is really the only mention we have as far as earthquakes. So I'm going to come on to talk about earthquake-proof pipes and hangers later on. But that's the only mention that we have in the UK, in Europe about that kind of thing specifically. No part of any support should be made of combustible material. Well, that's not an obvious one. Nails shall not be used. Again, that seems pretty obvious to me. Quick note, in TB201, TB201 is all about suitable sprinkler components and services. So it lists various components. So, for example, sprinkler heads. I've got this out in front of me, actually. The sprinkler heads themselves to 12259 Part 1. And so it kind of tells you, okay, you've got to use those kind of types of standards for each of those. And pipe hangers are listed in there. So there is an LPS standard So again, in one of the sprinkler talks, I talked about approval bodies. So yeah, I often refer to the LPCB. So we have the LPCB, the Loss Prevention Certification Board. We have the LPC, the Loss Prevention Council, and we also have the LPS, which is the Loss Prevention Scheme. So similar acronyms that all kind of mean the same thing. So yeah, the LPS is just the LPCB scheme, various numbers. So 1194 is entitled Requirements and Testing Methods for Pipe Hangers. So there is a standard out there for pipe hangers, which things should be complying to. Moving on to talk about spacing. So again, in general, we shouldn't have more than 4 meters between some kind of support for the pipework. However, this can be increased to 6 meters for larger pipes, so 65 millimeter pipes and larger, provided there are 2 independent supports and the support is capable of 50% more than what is listed in Table 40. So there's an example there on the right-hand side. So we're using 2 concrete anchors, and each concrete anchor is capable of the load plus 50%. Or is it maybe it's the whole bracket is kind of 150% of the total in Table 40. But yeah, you get the idea. We're just like our water supplies, superior water supplies, duplicate water supplies, building in redundancy. It's a bit like this with this bracket. We have multiple fixing points, and then it's kind of extra secure, which means that we can relax some of the other requirements, such as going from 4 meters to 6 meters maximum. Terminal sprinklers. Terminal sprinklers are where it's only supported on one side. So we're talking about coming off a distribution pipe, and it's only going in one direction. The distance from any terminal sprinkler to a support shall not exceed 1.2 meters, except 25 millimeters where it's 0.9. Again, I suppose I don't like this about our rules, that for me, it'd be easier just to have one rule for all pipe sizes, rather than always having this. Well, it's like this, apart from this size, when it's like that. But that's where we're at anyway. A distance from any upright sprinkler to a support shall not be closer than 0.15. I should say 0.15 meters. Sorry. 150 millimeters or 0.15 meters. So what that's getting at is that we don't want a support to be very close to the deflector plate of a sprinkler head, because it may impede the distribution of the water. So just like everything else that you need to watch out for in terms of obstructions of sprinkler heads, that we don't want the pipe supports to be one of those obstructions. So yeah, they need to be kept a little bit away from the deflector head. Arm pipes, similar thing. Arm pipes more than 450 millimeters long need to be supported. If they're shorter, then they don't. Some rules on vertical pipes. So any vertical pipe that's more than 2 meters long or more than 1 meter long feeding single sprinklers would need to have additional supports in place. And then pipe supports from mechanical joints. So this is an important one. So whenever we are connecting 2 bits of pipe together, so where we have a mechanical or a grooved coupling, should I say, or we are changing direction, or we're screwing one piece of pipe into another, then we're going to need a support within 1 meter of each joint. Okay, so within 1 meter of each joint, we need a support. Another mistake there, isn't there? It says 100 millimeters, so it should be 1,000 or 1 meter. And again, what this diagram here is showing is that we've got 2 joins of the pipe, so we need a support between each one, but we also need each piece of pipe needs to have a support. So if the hanger on the left-hand side, if that was moved more to the left, to the other side of the groove coupling, then you've got a support within that designated area, but then you don't have the support on that center piece of pipe. So yeah, that's something again to bear in mind. Each piece of pipe was going to need its own support. Then we have table 41 and table 40. These are talking about different types of supports. So you can see on the left-hand side there we have a bracket which is kind of gripping onto something, normally a supporting beam. And then we have some information in terms of the pipe clips and the rod sizes to be used. Similarly for table 40, we've got a different type of bracket there, and now we have different minimum load capacity, telling you the size of the bolts to use, and how even the anchor bolts that are used to secure it in place. So again, all those information is there. And remember that rule I told you about earlier about increasing it to 6 meters. So yeah, it's that plus 50% if you're going to increase it to 6 meters rather than 4. So all of those can be found in that section that I mentioned earlier in BSEN 12845. You can take a look at that for yourself. Moving on to other matters. So as I mentioned earlier, earthquake-proof or seismic protection on pipes. It's something in the UK that thankfully we don't have to worry too much about. We do get the odd earthquake here and there, but they're generally very, very mild compared to other places in the world. And we don't, as a rule, bother to put additional precautions in place to our buildings to protect them from earthquakes. Unless they're kind of high-rise buildings, I suppose. But yet, in other countries where earthquakes are very common, then that is something that has to be taken seriously with the sprinkler pipe work, because we don't want the pipes to fail. Obviously, the worst case scenario is that it completely breaks a major pipe, and the sprinkler system empties itself onto the building. And not only is that going to mean a load of water damage, but then it's going to need to be repaired, and you've lost sprinkler protection whilst all that is being taken care of. So there are things that we can do to protect our sprinkler pipework from earthquakes. So first of all is bracing. So those two images there are showing bracing. Bracing means stopping the movement in various different ways. So it's basically having brackets at different angles to support it from different directions. Flexibility, allowing couplings to move or to hinge, to pivot, so that when there's a kind of a shaking effect, that can absorb some of that impact. And then finally, clearance. So we don't want the sprinkler pipes to be too close to other services or to building construction, because then if it moves, we don't want it to bang into something else. Again, it's going to cause potentially more damage both to itself and to the other service that it's touching. Now, you might think that bracing and flexibility are kind of opposites, and in a way they are. I mean, one is trying to hold something tight so it doesn't move, and the other one is allowing it to move. So they are kind of different ways of what's the expression? Different ways of cracking an egg or something like that. I think that the point is that in all cases, it requires some thought in terms of the layout, in terms of local knowledge of what kind of earthquakes are likely, and then looking at where should we secure, where should we use bracing to kind of lock it all down, where would be best to allow some flexibility, and where should we allow for some differential movement. So, as I say, I'm nowhere near an expert on earthquake-proof brackets, but it's something that I've noticed that is available to purchase. Those images there are looking at other ways of increasing flexibility. So first of all, on the left-hand side, Things using spring-loaded equipment or dampened equipment, again, is just going to help to move, absorb some of that impact. The image on the top right is essentially putting a load of extra bends in for no other purpose than for when there is an earthquake and things are moving. It's going to help to absorb some of that impact. Some of those joints can kind of twist and kind of move and pull apart, rather than just having one long length of pipe. So from a frictional loss point of view, that's a really bad idea. But from an earthquake point of view, it's a good idea. And also, flexible sprinkler hoses are generally a good thing as far as earthquake proofing is concerned, because again, they're allowing for sort of extra movement. And I also found this device here from Metrofire, which is using that kind of principle, but for larger pipes. Again, just allowing for that movement to occur. So you're using this kind of threaded or braided kind of pipe in between. Earthing. So again, earthing is another kind of niche topic in terms of pipe. So yeah, same as copper pipes. Whenever we've got a kind of a long line of pipe work, then we do want to allow some earthing or bonding. The idea here, again, I'm not an electrical guy, but I believe that the idea here is that if you have a live wire which touches some of this metal pipe work, then the danger is that all of that metal pipe work will then become live. Whereas if we can earth it, then that will cause that electrical circuit to trip, and then we can go, right, we've got a problem, and we can figure out where the problem is and we can fix it. Whereas if there isn't earthing, then all of that pipe could become live. Again, anyone that touches that pipe will then come into contact with that electrical supply. So yeah, we do have earthing of sprinkler pipe work. Interestingly, again, I couldn't find any reference to earthing within the kind of the installation side of the rules, but I did find this in the service and maintenance side of things. So yeah, 20.3.2.4 is talking about inspection of pipework and supports. And whilst you're doing that inspection of pipework and supports, it says that they should be checked for electrical earthing connections. So I again found that interesting. It doesn't actually, as far as I could see anyway, it doesn't actually tell you to put them in, but then it does tell you to check for them as part of the service and maintenance requirement. Drainage. Okay, so let's talk about drainage now. So again, we've got quite a nice catch-all statement here in terms of, well, first of all, actually, the sprinkler layout drawings should show the drainage slope of the pipework. Okay, so that's something that needs to be thought about from the design stage. But yeah, this is my sort of catch-all statement here. Means shall be provided to enable all pipework to be drained. Okay, so every single bit of pipework, ideally, should have the ability to be drained. Now, the easiest thing to do is to slope all of the pipes so that the water will naturally run back to the installation control valve. So the installation control valve, we have a kind of a main drain point, which is normally, well, almost always hard piped into a drainage setup. So opening that up is a nice, easy way of draining. And to say, if you can imagine, like a tree, I guess, all of the branches are kind of sloping back towards the trunk. Well, that means all the water can come out of our alarm valve. But of course, that isn't always possible, and therefore we're going to have extra drainage points scattered around the building, scattered around the pipework to enable all pipework to be drained. But as I mentioned in the, I think it was a previous sprinkler talk when I was talking about live tap, that's very difficult in practice to achieve. So we can use live tap to add extra drain points, but often it will just be left. There'll be a small pocket which doesn't fully drain, and that may just get ignored. For dry and alternate installations, there actually is some information in terms of what slope we need to allow for. So distribution pipes of 0.4%. I kind of converted that into 1 in 250, which makes more sense to me than percentage. Distribution pipes will slope to the drain valves with at least 0.2%, which is 1 in 500. So for dry and alternate installations, there is specific slope requirements need to be met. For wet pipe work, it's just basically down to the designer in terms of making sure that all the pipe work is available to be drained. Okay, let's talk about painting. It's 17.1.7 says all galvanized ferrous pipe work shall be painted if environmental conditions make it necessary. It seems to me that it's very unusual not to see painted sprinkler pipe work. It does seem to be done, regardless of the environmental conditions. Galvanized piping shall be painted wherever the coating has been damaged by threading. So again, I think this is something I've mentioned before. But yeah, you can buy pots of essentially kind of galvanized paint solution. And when you're screwing a piece of galvanized pipe, you're taking the coating off. When you then screw it into the other end, if there should be, or there normally is anyway, some thread which you've threaded but hasn't actually gone into the fitting. So then that's exposed. So that will just need to be touched up with say a paint pot and a brush. The actual sprinkler pipework itself is generally painted in red oxide. It's like a primer, to be honest. But yeah, that's normally what's done. Is this red oxide paint coating on the outside, and then it's just left alone. So yeah, we normally have red. Seems to make sense to me. Fire, red, and makes sense. But yeah, there's no requirement for it to be red. It can be a different colour. And I know we did some work at Canary Wharf, and the sprinkler pipes in Canary Wharf are grey. So yeah, grey or red seems to be common colours to be used. There's even a section here on pipe work and pipe supports. The pipe supports need to also be checked for corrosion and painted if necessary. But again, I don't think that's often necessary to do. Let's talk about painted zone checks now. So here on the right-hand side, I've got a picture of quite a typical scenario. Could be a retail unit, could be a restaurant, where they have painted the whole of the ceiling black. All white, but yeah, you've got an exposed ceiling, so you've got the services on show, and then just paint the whole thing. They kind of get a company in with a sort of spray paint system, and they coat the whole ceiling to be a plain colour. So yeah, I have had various people asking me about the fact that the painters have gone in, and now your zone check is completely black or white or grey or whatever, and they're asking me, is that a problem? So the first thing to say actually is that obviously you mustn't do this with sprinkler heads. So again, I'm not quite sure how they do it, to be honest. Either they remove the sprinkler heads, paint the ceiling, and then put the heads back in again, or they go round and they would tape them off or kind of cover them up somehow, paint the ceiling, and then take the covers off. And I'm not quite sure which one they typically do. But yeah, I think people are pretty hot on that, the fact that we shouldn't be painting sprinkler heads. Of course, if you wanted your ceiling to be black, then you can buy black sprinkler heads that have already got that paintwork on as manufacturer supplied. So that can be done for sure. But yeah, talking about our zone checks. So yeah, our zone checks standard come as red, but there are other equipment on there. The flow switches. You've got the isolation valve. You've got valves around the pump, etc. So yeah, people ask me, okay, well, it's now completely painted black. Is that an issue? I mean, the first thing to say is that essentially, if the zone check works, it works. That's the primary thing. If that the paint shouldn't cause a big issue in terms of the actual workings of the zone check. So yeah, if we can run it, if it pumps the water, if it trips the flow switch, then largely it's job done. However, we wouldn't recommend the zone check to be painted because of the following reasons. So first of all, we do have some moving parts, such as the valves either side of the pump. So if the pump ever needs to be replaced, we need access to those. Same with the zone valve. So if the zone valve has been painted, again, that wouldn't be recommended, because we need to kind of get to it. And there's also an indicator paddle on there, which is important to show you whether the valve is open or closed. The flow switch and the zone valve, should be readily accessible and identifiable for emergency shutdowns. Okay, so our zone check is not important for emergency shutdowns, but the flow switch is. So again, if that's now got the same colour as the rest of the ceiling, it's going to be harder to spot. Painting the zone check, as I say, may void the warranty. I mean, probably will void the warranty, to be honest. I think that there would be a little bit of common sense applied there. If the fault is nothing to do with the fact that it's been painted, then there may be some common sense. But obviously, painting it means that we can't then resell it, which is the main point. The zone check manifold is it's already finished, so it comes as standard in a red Plascoat finish. And we do have custom colours and paints by request. So we have sold white zone checks, are quite popular. We've sold them to various car showrooms. Seem to be quite keen on the white finish. And talking of which, we also have custom zone checks, including this one here, which was a solid gold design. So we've got nice shiny 24 karat gold on our zone check there, which is obviously a price on application. Is it 1st of April? So next week we're going to be looking at approval bodies part 2. So in part 1, I focused mainly on the LPCB. So in part 2, I'm going to be looking at some of the other approval bodies that are out there. And that's going to be covered next week. All right, thanks a lot for tuning in. As usual, I'll just stick around and see if there's any questions and comments that come up in the chat, and I'll do my best to answer them. If you want to send me an email, it's sprinklertalk@projectfire.co.uk. All right, thanks a lot. Enjoy your Easter holidays, and I'll see you next week.